Good evening, everyone. Yesterday we discussed about the isolobal structure amplification. So today give some examples. So that some examples is the compounds. Last time we discussed about MnCO was 5 times. So this compound also reaction of the compound and the reaction of metal carbonyl fragment is MnCO 5 times. May thus it related to similar one of chloride. We already know the chloride is a seventh group element. So 7 valence is Ns2 Np5, 7 electrons is there. Here 17 electrons. So for satisfy of 18 electron rule, you need 1 electron. For chloride, for a satisfy of octet rule, they also need 1 electron. And methyl group CH3, we already discussed in the previous. So they have also 7 electrons. So need 1 electron. So these three are here we discuss the chloride minus chloride. So chloride ion also the chloride ion, the chlorine also has MnCO 5 times and chloride and CH3. These three are isolobal to isoelectronic to each other. Okay. Next we discuss about they are the formal free radicals, and much of their chemistry derives from the pairing of electrons. Pairing of odd electron. Odd electron means one more electron of these particular clusters. So here the manganese carbonyl cluster normally exists as dimer Mn2CO 10 times, when chloride has Cl2 and methyl free radical it is act as a dimer of C2H6. So CH3 CH3. Furthermore, we are combined with the other species having single unpaired electrons like alkyl free radicals R radical and iodine radical to form a neutral. So this alkyl is combined with either MnCO 5 times, or alkyl group is combined with another chloride, or alkyl group combined with either methyl radical, whereas MnCO 5 times is combined with the iodide, and iodide combined with the chloride, and C is 3H3 minus I. So all these fragments is nothing but chloride and MnCO 5 times and methyl radical all are combined and form a group electronically equivalent groups, whereas isolobal fragments. The next concept, here again we discuss some more examples. So here the Hoffman suggests that the Hoffman radical point out there that any fragments which are filled sigma type orbital may be able to form structural similar to those formed by the methyl group. For example, methyl group. So here the iridium. So in the iridium CO taken thrice. He has iridium. We already know this is the cobalt series, cobalt, rhodium, and iridium. It is a D7. So D7 is 7 plus 2, 9 electrons, whereas plus cobalt, carbonyl group 3. So this carbonyl has 3 into 2 electrons. So 6 plus 9 electrons, it is again 15 electron fragments. So this is isolobal with CH. CH means again carbon is 4, 1 electron, 5 electrons. So it is obey for the octet. 18 electrons to 3 electrons. It is obey for the octet. They also need 3 electrons. And phosphorus, we already know nitrogen, phosphorus. Nitrogen is a fifth group family, whereas Ns2Np3, so the valence is 5 electrons. These also need octet for 3 electrons. Each of these possesses 3 electrons less. So hence these clusters, iridium 4CO 12 times is isostructural with CH4. It is also a tetrahedral structure, we are well known, as well as phosphorus. So the phosphorus also in tetrahedral arrangement, the 4 corners of the tetrahedral occupied by the phosphorus atoms. So these three are isoelectronical and isostructural for these 3 fragments. So this one and this one and this one, and the structural complete cluster, this is also tetrahedral structure. So one more example is iron cluster. So iron CO 4 times. Iron we well known, it is a D6 group. So 4H2 3D 6 plus 2 8 electrons, and electrons for the carbonyl group 4 carbonyl groups is there. So 4 2 is 8. 8 plus 2 how much? 16 electrons. So to obey The 18 electrons should need 2 electrons, whereas CH2, so methylene group, the CH2 group has also 6 electrons, carbon is 4 and 2 is from the hydrogen, total 6. So 2 electrons are short to obey 18 electron valency as well as octet rule. So this is a 1 hour example for the Hoffman isolobal principle, isoelectronic and isostructure. So the next concept we go for, we are on the classes also we already discussed about octahedral of molybdenum 6Cl8 4 plus and niobium 6Cl2 plus. So first we discuss about this molybdenum. So these two of clusters, how many metal atoms is there? 6 metal atoms, 6 metal atom. Clusters of 6 metal atoms has been known for the many years. So the first in these first type of clusters, octahedral of 6 metal atom is coordinated by 8 halides. How many halides is there? 8 halides. So in the second type of cluster, the octahedral of 6 metal atoms is coordinated with 12 halides. Now we discuss about only one of the structure, octahedral halide of molybdenum cluster. So in this cluster, molybdenum is plus 2 state with T4 configuration. We are well known. So here the molybdenum. So the molybdenum in the which series, chromium, molybdenum and tungsten, whereas NS 4s2 3d4, here 5s2 4d4. The plus 2 configuration we do 2 electrons from 5s, and we have 4d4 configuration. 4d configuration means 4 electrons in the valency. So again we discuss about the structure. In this structure we assume this cluster in a cube that are central of each face of cube there is a metal atom, and each corners of cube is there is a cluster ion. So here um, for Telugu medium students I tells about me ఒక ఒక క్యూబ్ని ఊహించుకుంటే each face of the cube is a metal atom face. How many faces is there? Six faces. Again corners అంటే ఎన్ని మూలలు ఉన్నాయి? 8 మూలలు ఉన్నాయి. 8 మూలల్లో ఏముంటాయి? Chloride atoms ఉంటాయి. So each face, so in a cube we have 6 faces. This is a one face, second, third, fourth. So side faces is the central face of this one, this face for this one. So we image all these 6 faces of a cube. You arranged in here the 6 molybdenum atoms. So here the molybdenum atoms are arranged in an octahedral manner. So same 6 atoms are like this. Again you draw the middle of that particular square is like this square. Okay. So one of the top corner, this one. Bottom corner, this one. Okay. So there is a bridging halogen on a central each face of the octahedral. Each metal atom is coordinated with the 4 chloride atoms. So this is the metal atom. So these are the chlorides. You already know the corners of the cube is chlorides. So this metal atom is attached with the particular chloride 1, 2, 3, 4. Okay. So like this all these cluster is arranged like this. Okay. So here coordinate to 4 chloride and bonded with 4 neighboring atoms. So this chloride also attached with the 4 neighboring atoms. So one of the this chloride is attached this one and this one and this one. The one more is this one. Okay. So here each chloride of a particular metal atom is surrounded by each metal atom. So here each metal atom has 4 electrons, 4 orbitals. So which is the form 4 bonds with the 4 neighboring metal atoms. So how it is possible? Again we discuss this texture. So this is a metal atom. So this metal atom is coordinated with this one and this one and this one and this one. So here we already well known structure is this one. So this metal atom is surrounded by 1, 2, 3 and 4. So each metal atom is surrounded by 4 neighbor metal atoms. Okay, so all the electrons, so how many metal atoms, electrons is there? One metal atom, so 4 electrons. So how many metal is there? 6 metal atoms. So 6 into 4, 24 electrons are involving in the bonding. Therefore the cluster is diamagnetic. There is a single bond, there is no one another bond is there. All there is a single bond adjust between the metal and metal. So here we discuss about, here there is a single bond between metal and metal. So the overall structure is drawn like this. So here, so one more of electron. So we draw a cube first. I draw a bigger size. Okay, so again we draw another cube. Okay, sorry, it is a mistake. Sorry. ఒక క్యూబ్ను ఊహించుకోండి. ఈ క్యూబ్లో each face, this is the one face. ఈ ఫేస్కి, ఓకే, ఈ ఫేస్ది సెంటర్, కరెక్ట్గా సెంటర్ చూసి పెట్టుకోండి. another face 1, this face 1, this face 1, this face 1. ఓకే, సో ఈ నాలుగిటిని మరలా దీస్ 4 సైడ్ ఎడ్జెస్ మనం ఇంతకు ముందు వేసుకునేటట్టు ఇట్లా. ఓకే, నెక్స్ట్ ఈ టాప్ 1 ఇంతకుముందు మనం వేసుకునేటట్టు. ఓకే, బాటమ్ ఇంతకుముందు మనం వేసుకునేటట్టు. ఓకే, సో అగైన్ we draw like this. This is a well known structure for you, this top. సో బాటమ్ ఫేస్ చేసాం కాబట్టి ఈ బాటమ్ లైన్ తీసుకొని ఇట్లా ఫేస్. ఓకే, నెక్స్ట్ ఈ బాటమ్. Okay, okay, so this structure is completed. Again halogens అని చెప్పాం. The corners of the cube is halogens. Okay, so ఈ corners of cube halogens అంటే ఇప్పుడు ఏం చెప్తాం? The dot line is metal and the circle one is ligand. Okay, okay, so again all the metal atoms is surrounded by neighboring of 4 metal atoms, 1, 2, 3 and 4. Again the halogens act as a bridge ligand. So this metal atom also combined with the neighboring of 4 halogens. Okay, again this metal atom, this halogen also combined with neighbor of 4 metal atoms. So one is completed, second one, third one, the another more is this one. Okay, so draw all the structures like that. We get a overall structure of metal cluster of molybdenum complex.